Hi students, Mr. Clucky here. So I'm going to talk through you our task 2 directions here and our task, which is going to be creating a cause effect table using some of the links provided on the Google HyperDoc itself. I'm going to genie myself here a little bit smaller and put me off to the side. So remember, we're looking at this task 2 right here, which is tracing our cause effect relationships. And to do this, we need to make a copy of this cause effect handout. And then as we watch this video that you're listening to right now, we want to be filling out our answers into this cause effect handout. Okay, so I'm going to go ahead and make a copy of the handout like you guys should have already done. And then I'm going to also go to our PowerPoint presentation to kind of talk a little bit about this handout. Okay, so we've seen these before. We did one of these back in lesson 6 before we took our tests to try to think about what are some of the things we've been doing to our system in the lessons. And you'll see I have some of these ideas in here, but we need to watch this video to fill in the rest of the information. Okay, so where we'll start is right here on slide C. So I'm going to locate that slide. And there it is. So on here, I want us to go ahead and think about that. In lesson 6, we made a list of some cause-effect relationships that we thought were important. And remember, some of those were like, when we put a north to a north, they repel. When we put a north to a south, they attract. What's going on in the visible space around the two magnets? So we did a few of those. When we did this, we observed some things in class from lessons like 2 through 6. Well, I think we have some new cause-effect relationships that we want to show that we've been learning about, and we want to put those in a new table. So now that we've done some of these more investigations, we're going to take a moment to look back in our notebook for some ideas and look for specific changes that we made to our systems in lessons 7 and 8 and the effects that we observed when we made those changes. So I want you guys to, before we complete the table, I want us to go back to our worksheets we've been working on. If you got your notebook with you, go back to your notebook. But I want us to specifically look at that table that we worked on in lesson 8 and the investigation we did in lesson 7 about energy. So think about what are some changes we made to the system in lesson 7 when we were working with the cart, the bumper, and the two magnet system. And then what were some of the changes that we made to our system of the speaker in lesson 8? So now that you've had a chance to think of those ideas and go back to our notes we've taken, we're going to go ahead and we're going to fill in some of those relationships. Okay, so I am going to go to my copy now, and we're going to fill out this chart. So I want to first look at, let me make myself a little bit bigger here. I want to first look at lesson 7. Okay, so one of the things that we did in lesson 7 was that we brought the magnets closer when the forces were what? And those forces were repulsive in that instance. Okay, so in lesson 7, we brought two magnets closer together when they were repulsive. And when we did that, what did we observe about them? And you'll notice that if the magnets are repulsive, they will move back apart or further away. Okay, they will move back apart. Now, we need to explain why they did that. So to explain that, we need to use energy in our explanation. And we want to talk about how energy was stored in an area, and that area was the magnetic field. And that magnetic field transfers energies or transfers into the what of the magnets as kinetic energy. And remember, kinetic energy is motion. Okay, so it's going to be transfers into the motion of the magnets, in other words, kinetic energy. So that's the process we're going to go through. And now we're going to go ahead and do the rest of these. So there are 1, 2, 3, 4 more we need to do. Okay, so now we're going to do the next one. The next one reads that in lesson 7, we brought the magnets and did something to them when they were a different force. In the first instance, we did repulsive. So on our worksheet, we read that what if we brought the magnets further apart when they were attracted? That's one of those questions we answered on that worksheet. When we did that, we saw though that they would, how would they move? And we saw that they should move back together if we pulled them apart. And the reason for that is the exact same, the magnetic or the energy that was being stored in the magnetic field transfers into the motion, and we see it as kinetic energy. Okay? Remember, at any point during this video, if I'm going too fast, you can always pause the video and write those things in as I'm talking. You have the ability to do that with these videos. But now we're going to move on to the third one, which is something in lesson 8. So these next 3 things are areas that we investigate in lesson 8 with those different video whole class investigations. So in lesson 8, one thing that we did was we connected something, okay? And in this lesson, we connected music, a music player. We connected our music player to a light bulb instead of a coil of wire. Now, when we did that, what did we see the light bulb do? Okay, so when we connected a music player to the coil or to a light bulb instead of a coil, we saw that the light bulb's brightness changed with the volume and pitch. Okay. Now, why was it changing brightness? Well, what's coming out of the music player? The electric current. So there is an electric current coming out of the music player that is changing all the time. And it's changing in direction, but also in strength in respect to our volume and our frequency. And in the battery, it only had one kind of current, right? And in that one kind of current, the strength didn't change and neither did the direction unless we manually turned it. So that's the reasoning for that explanation. And then we've got 2 more to go through. So there were 2 more things that we did in lesson 8, right? And one other thing that we did was we switched the poles of the battery. And if you remember, we did this with the LED investigation. Now, when we switch the direction of the battery, we switch the poles of the battery, we notice something happened. So the light bulb turned what color? Well, it was green, and it turned to a different color, which was red. And it went back and forth as we alternated the direction of that battery. So, and the light bulb turned from green to red and back, alternating with the direction of the current. And then we also want to add the poles of the electromagnet switched. Now, they did this for a reason. And that reason is that there is, again, an electric current coming out of the music player that is changing all the time, whereas the battery only had one kind of current, and it changed in strength and direction. Now, last one we want to go through is in lesson 8, and we connected something again, and that was our coil. And we connected our coil to the music player instead of our battery like we usually have done. Now, when we connected our coil to the music player, we observed something happen, and it was with a certain device next to that coil of wire. And what was that device? It was a compass. So the speaker, right, and when we put the compass next to it, we noticed that it kind of vibrated. So the speaker vibrates or moves back and forth. So when we connect the coil to the music player instead of the battery, the speaker vibrates and moves back and forth. And the reason it's vibrating is because, as in our other explanations, go back to electric current. There's an electric current coming out of the music player that is changing all the time in direction and strength. And that changes the shape of the magnetic field around the electromagnet. I spelled shape there. There we go. So at this point, make me a little smaller here. We should have this entire table filled out. Now, this table is something that should be saved in your Google Drive now. So you want to hang on to this because you will be able to use this table as you prepare for our upcoming assessment that's going to happen sometime in early January, probably right when we get back from winter break. But this is a great summary of the information we've been learning. Okay, so make sure you retitle up here what it is. And then after this, if we go back to our Google HyperDoc, I want you to try out these relationships with the interactive. So if you click on this link here, we've got an interactive in a lot of different situations where we were able to set some magnets. I want you to think back through our cause effect handout, and I want you to represent some of these situations using the magnet in the coil of wire. And you'll notice now we see the direction of the electric current. So here in the coil of wire, it's going from the north to the south, and we can see that's coming out of this end through here and back to our battery. I can also switch the polarity, so I can make it go from positive to negative the other direction now. And notice when I switched the polarity of the battery, it changed the direction of the current. And I can also switch it off. So I want you to try to represent some of these different things that we talked about in our cause effect handout with the simulation, and just look and kind of reaffirm what we know about our system, okay? So try to represent it, play around with it, but this should reaffirm what we know about magnetic fields and electric currents now, okay? Thanks, guys.